And welcome back to the walkthrough videos for the NSA Codebreaker Challenge for 2020. Again, my name is Jacob Elliott at the University of North Georgia, and right now we're going to be looking a little bit at Task 4. Now, similar to last year's challenge, the difficulty really starts to ramp up here almost immediately at Task 4. So they would expect that some people would be able to complete the first couple of challenges fairly easily with a little bit of introductory experience. But when you get into this Task 4, you're going to find that it is actually very difficult to figure out unless you have a little bit of knowledge about, as they mentioned here, graph algorithms and basic computer science. So, as you may recall in Task 3, we were able to recover the Stepinator account that the journalist that was kidnapped used for their fitness tracking. And so they've actually downloaded the accelerometer data from that device at the time of the kidnapping. And this task, we're actually going to be looking at trying to use that data to figure out where the journalists may have ended up a few minutes after their kidnapping and try to locate the closest intersection to where the terrorists may have taken them. So they provide us with a couple of different files here. The readme.txt with additional instructions, the acceleration data itself, and then a city map and traffic light schedule. So when we go here and look at the readme, it explains that the device doesn't capture GPS data, but it does capture one data point per second for the current acceleration that's being experienced by the journalist wearing the fitness tracker. So what we're essentially able to do is break down that data to try to figure out where the terrorists took the journalist after they were kidnapped. They explain that each city block is about 100 meters long, and they provide a map that shows where the traffic lights are and what color they would be at each time measured in, we'll give it T equals, and basically explain that it cycles every 30 seconds. The kidnappers obeyed all the traffic laws and speed limits. Right turns on red are not allowed. And they would likely slow down when they take a left or right turn. So this will kind of help us because we can use that acceleration data to figure out when they were actually turning. And again, they would not loop back the same way. So you can assume that once the intersection is traversed, they're not going to come back through it again. So now we can look at the actual Stepinator data itself, and we can see these acceleration measurements here. And you can assume that these 1.5s are going to be some kind of just constant acceleration, and then negative acceleration, meaning they're slowing down, and then zeros. So at this point you can kind of interpret that they've accelerated to full speed for some period of time and then slowed down to a stop, and then they've stayed still for a little bit, then sped up again, continued at top speed, and then slowed down again to a stop. So we can kind of use this information to figure out what's happening here. And a little bit of Python can really help us to kind of parse this. So I've gone ahead and created just a simple script here in Python I call task4.py, and I'll explain what exactly we're doing here. We want to be able to parse this acceleration data and be able to determine kind of how far the journalist traveled in one direction before they either turned or stopped or continued moving. Then we can use little cues from the acceleration data to figure that out. This program loops through each of these data points and tracks the velocity of the car at the time and then how far they had moved since the last turn. If the previous acceleration point was less than 0 and the current one equals 0, then it means they had negative acceleration and were slowing to a stop. Then, if the previous point was 0 and the current point is greater than 0, it means they started moving again. Then finally, if the previous point was less than 0 and the current point is greater than 0, it means that they slowed down momentarily to make a turn and then continued accelerating. So now we can run this program and it tells us exactly how far they traveled in blocks before each action they took, whether it be stopping, turning, or continuing. So let's go ahead and look at the map and we can try to figure out exactly where they ended up based on a little bit of logic as we go through it. Let's consider the city map that we're provided. This pink color here indicates the starting position where the journalist was actually taken. Now let's go ahead and switch over to our initial traffic light map at t equals 0. We know from the provided instructions that the car begins by heading east, and then from the output of our script we can tell that they travel one block and then stop at t equals 14. Now at this point, they wait until t equals 13 to continue moving again. So we need to swap out the map so that we can show the light pattern at the 30-second mark when they all change. Now at this point, we know that the car continues for 2 blocks. And so even though the light has changed, because the vertical lights are now red, we know the only possible option is they continued horizontally east for 2 blocks. Now once again, the car has reached a horizontal red light at t equals 51, so they have to sit and wait for the light to turn green. Now the car actually has 3 options. We know that it can go north, south, or continue moving east, but we know that it goes for 1 block in that direction and then turns. However, if we recall the rules of this, because the vertical lights at t equals 73 when they make the turn are all red, it means that they couldn't have legally made a turn while the lights were still red. So they must have continued east where they would encounter a green light and then turn south. At that point, they reach a vertical red light at t equals 84 and have to wait for the lights to change again. If we look at the next move, we can see that the car is going to move 1 block and then stop. However, we can look at this logically to figure out which way they went. If the car continued east, then they would reach a horizontal green light, and so they'd have no reason to stop. If they went south, they'd reach a vertical green light, and also have no reason to stop. However, if they went west, they would reach a horizontal red light, and therefore have a reason to stop. So that's the only way that they could go. At t equals 120, the car can continue moving again. We know that they could go 1 block west and stop, or they could go 1 block south and stop. However, they can't go north, because that would cause them to cross back over the path that they had already gone on. And now again, they wait for a few seconds for the lights to change before continuing at t equals 150. The next move ahead is to move 1 block and then stop. If we look at the options, we can see that the upper left car has 2. It can either go west, where it would run into a green light, and it would have no reason to stop, and it can't go north because it would cross over the path that it already passed through. So the only option is for this car to go south. Considering the other option, if the other car were to go south, it would run into a green light and would have no reason to stop. However, it could go west, where it would reach a red light and stop there. So we're back down to only one option again. Now, at t equals 180, the lights change, and both of our cars, they're still stacked on top of each other, can begin moving again. Now, the car that was heading south in the previous move could either go east or west here. But we can eliminate the westward direction because they would run into a red light horizontally and they wouldn't be able to make a turn on red. So we know that that car would have had to go east. And the car that was heading west in the previous move can also not continue going west because of the same problem. So they would have to go north. For the next move, both cars will stop at t equals 204 and wait for the light to change. Because of the paths they've already taken, each car only has one valid move that they could possibly take. When the lights change for the final time, both of our possible cars will make one final move before we end the accelerometer readings. The top left car can't go north because it'll cross the path that it's already been passed. So it can only go either west or south. The other car can only go east or south, but that leaves us with 4 possible locations where the kidnapped journalist may have been taken. Unfortunately, the creators were forced to implement some additional wait times to discourage people from brute forcing this challenge, but after a little bit of trial and error, I was able to determine that the correct answer was this car at L10. You can see how this challenge definitely takes a little bit of graph theory, as well as just some logical thinking to be able to figure out. But now we've been able to narrow down where the kidnapped journalist was taken in the minutes after their original kidnapping, and we can continue on to task 5.